In this video, we will solve some more inequalities and we will write our answer using interval notation. These were in the slides for 1.5, so just that's if you're wondering where these were. These practice problems are on there, and we will just run through a few things, and there are a few properties I wanted to remind you about as we're solving an inequality. But let's look at the first example here. I'll go ahead and copy it on the right. 14 plus 5x is less than or equal to 9 plus 6x. And before we get started, all the strategies we reviewed from equations back in that very first lecture are the same exact strategies you want to apply to an inequality. So when you're solving an inequality, there's very few differences between them. Basically, you want to put all the x's on one side, put all the numbers on the other side, and get x by itself. So the goal is to get x alone. Once you're there, you're basically done. But you also want to graph and or write the answer in interval notation. But basically, notice I would first look over the equation or inequality. It's not technically an equation because it's not just equal. But I would note that I have 5x and 6x. So, I want to move one to the other side, and I have 14 and 9, same thing. I want to put, all the numbers on one. And another one of those recommendations was that you always want to subtract the smaller one. So what I would do is I would subtract 5x from both sides here because that would keep it positive. And since I'm basically moving that to the other side, that would leave me with actually just 1x or x. I would also move the 9 from the right-hand side to the left-hand side, which would leave me with 5. And that would get x all by itself on one side and the number all alone on the other side. And so this is a little messy, so let me rewrite this. But basically what I'd be left with is, well, also notice that when you put x on the right-hand side, this can actually be a little bit trickier to read because it doesn't say x is less than 5. This is actually saying 5 is less than x. But another property that's a little different between an equation and inequality, like the thing about an equation, if I have x is equal to 5 and 5 is equal to x, those things mean the same thing. It doesn't matter which way I write them because if something's equal, it's equal no matter what order it comes in. But an inequality is not the same if we switch the order. So if I wanted to invert the sides of the equation, say I wanted to write x on the left-hand side because that's more common, I would also have to flip the direction of the inequality. Because if I read this, what this reads is 5 is less than x. And if 5 is less than x, that implies x is greater than 5 or equal. But that in this case, it doesn't matter because of the direction. But notice that these two statements are actually identical. And so, how I like to say it is you can read the inequality backwards, x greater than 5. Even though this is a less than symbol, it's because it's backwards. So, or, if it makes more sense to you, you can just flip it back. But make sure that if you're flipping the sides of the equation, the inequality also must flip. And then so, technically this is a fine answer, but why I recommend flipping it back to the standard form is because when we're then trying to graph our solution, we have the set of numbers which are greater than 5. So 5 is somewhere to the right of 0. And I'm trying to graph it. Well, since it's less than or equal to or greater than or equal to, depending on how I want to write it, I would use a solid dot, as I was saying before, to indicate that, well, 5 is an acceptable part of this solution because its x is greater than or equal to 5. And, 5 is equal to 5. It's greater than or equal. It's not greater than, but it is equal. And numbers such as 6 or 7 or 8 are also greater than 5. So we shade to the right, of course, because x is greater than. But the reason why I warn you is because this is a mistake I've seen with some of my students is, well, it looks like 5 less than x, so less than means shade to the left, which is true, but 5 is less than x, it's not x is less than 5. So that's what you got to be careful about, and that's why we're actually shading to the right here and not to the left. Because notice numbers like 4 or 3, they don't make sense in this inequality. So it doesn't make any sense to shade to the left in this case. But another way is if you just put x on the left-hand side, you can find the direction of shading based on the direction of the arrow within the inequality. And if I were to write my solution using interval notation, as the instructions say, it would be all numbers from 5 to infinity, because there is no limit to numbers which are larger than 5. It's going to keep going and going forever. And interval notation is always written from left to right based on my shaded interval where the left endpoint is 5 and the right endpoint, there is none, infinity. So 5 comma infinity indicates all numbers in between 5 and infinity. Putting the bracket around the 5 just indicates that 5 is an acceptable answer in my inequality. And again, as I said, always parenthesis on infinity. I said that in the last one. And so those would be different forms of our answer. Or again, if we wanted to use set builder notation, we just write the set of numbers x such that x is greater than or equal to 5. And that would be all the different ways that we could possibly think to write that. Well, technically there are more ways to write this too, but these are the most common and the ones you are going to need to know. So let's just do one more and then we will wrap up this video. But say we had fractions or decimals, or we wanted to use things such as the distributive property, all other algebraic steps would be the same. So like in this case, we could multiply, say, by 20 to cancel out the LCD. Here, we could just multiply through, and we would still try to use all the same strategies we applied from solving regular equations. So let's look at the second example, because there is one thing that is, well, there's actually a few other rules that are important with inequalities that we will probably discuss later. Because when you work on harder equations, new wrinkles and new strategies appear, and the same apply to inequalities. And we'll be dealing with inequalities from time to time. But starting with this one, well, first step is to try to get x by itself. So I have numbers on both sides. So what I would do is I would subtract 13 to the other side. 19 minus 13 would leave me with 6. And then if I want to finish getting x by itself, since in this one we had minus 2 times x, the way to cancel multiplication is by division. Remember, adding 2 here won't work because this is not, it's not x minus 2, it's x times negative 2. And the only way to cancel multiplication is to divide both sides by the coefficient. Because negative 2 divided by negative 2 will make 1. But the rule that I wanted to review here is, well, negative 2 and negative 2 will cancel itself out, is that when I divide or multiply both sides of an inequality by a negative, we have to change the direction of the inequality symbol. And then 6 divided by negative 2 would be negative 3. And so this was just a rule that you probably remember this rule, but it's a friendly reminder with inequalities. And there are a few other rules that inequalities, when it comes to harder equations, that are very similar to this. But a lot of times we're taught to, like, I remember learning this rule, and like my teacher just told me, okay, yeah, you got to do this. But I didn't know why. So why? Why do I got to change the direction? Why does that make sense? So that's what I wanted to mention here for just a second. What's the reasoning behind changing the direction? But really, it's quite simple. And so what I'll do is I'll look at a new inequality. Let's just say, let's choose something really easy, like 5 is less than 7. Let's choose an inequality without any unknowns, one that's just a true solved inequality, right? 5 is indeed less than 7. We can all agree on that. Now, let's just say we were to multiply or divide through by a negative, as I did over here. Let's just say I divide both sides by negative 1 to keep it really easy. Well, I would have 5 divided by negative 1, which is negative 5. And let's just say I didn't know I had to change the direction, I left it. And 7 divided by negative 1 is negative 7. And what this would leave me with is negative 5 is less than negative 7. Which, if I didn't really think about this, it might seem correct still. But remember that with negatives, negatives like debts are often considered bad, or not necessarily bad, but negatives are all opposite from positive numbers. They always do the opposite thing. And same is applied to inequalities, that if I have negative 5, technically negative 7 is less than negative 5. And if I was to look at it on a number line, right, I would have 0, negative 1, negative 2, negative 3, negative 4, negative 5. Here's negative 5, 6, negative 7, here's negative 7. Negative 7 is less than negative 5. That, it's not greater than, because on the number line, everything is ordered from smallest to largest. Negative 7, definitely smaller. And so I should write it this way, because negative 5 is actually greater than negative 7. It is less negative. And if I was to think about negative numbers, like just say debt. Debt is an example I like to use a lot. Let's say I was thinking about owing my friend $5 or owing them $7. A debt of 5, well, technically, if you're thinking about just the number, it's a smaller debt. But in terms of what is like, if I think about my net income, like the amount of money I have, not income, but just the net amount of money that I have in my possession, owing my friend $5 is a smaller debt than owing my friend $7. But I have more money if I owe $5 versus owing $7, right? Because I'm less in debt. So I really have more. It's greater. Anyways, I'm not trying to review the basics of inequalities. I'm sure you all know it, but I just thought I'd bring that up. And so getting back to the key idea here is, why do I have to flip the direction when I'm dividing by a negative? It's because dividing by a negative, or same with multiplying by a negative, or just negating an equation in general, is the inequality switches because the equation is opposite. When I multiply by negative, everything gets flip-flopped. Kind of like how when I switch the sides of an equation, it must flip. Same goes for multiplying through by negatives or dividing by negatives, because the whole thing will get reversed. And that's just a basic property of how inequalities must behave. And that's, anyways, that's the reasoning. So getting back to this, dividing by a negative, whenever you have a negative coefficient on x, you can kind of just remember that it's going to switch directions at the end of the day. And so finishing up with the inequality, well, again, that would be all numbers less than -3. So on my graph, I would use an open circle because I'm not including equals, as the original inequality stated. And that would be 0. And so with interval notation, I would have from -infinity to -3, not inclusive. And with set builder notation, again, it would just be brace, x, line, x less than -3, and brace. And again, meaning just a set of numbers that are given by x where or such that x satisfies the inequality. That's it for this video. In the next video, I wanted to talk about what are called compound inequalities. Basically, let's say I had two different inequalities and I tried to jam them together and think about what would be the net impact of those separately. And we'll review this more in class on Wednesday, right? Yeah, I believe, no, sorry, Tuesday. We're gonna come back and talk. Got my days mixed up for a second. We'll talk more about this idea on Tuesday